I think the introduction will read, so you can take it from your team introduction and take it from there. And there are going to be 2 more projects to go. One on our thesis that's going to be presented by Muntasir. And of course, last but not least, don't get mistaken by the order of posters. It's fully random. The last presentation and one of the best topics for me personally, with a special interest in it, Stellarium VR. The announcement that I wanted to do is, unfortunately, because of other commitments that we have at the administration level, I have to step out of the room at 4:30. So I apologize, but I leave you, all of you, my guests, the faculty and the, yeah. So I leave you all, the students, the guests, and the general audience in good hands with my colleague, my dear colleague, Liberty Page, who is,
I have a request.
Go ahead.
Can these teams record their presentation?
They have already a pitch, elevator pitch recorded for the presentations. But you want to record their performance here today?
Their performance here today, I want to see them.
Will anyone start a Zoom link and record this? I can do that. I can. What's that?
You can do that with your camera.
Yeah, I'm gonna start a Zoom link, and I want someone to just use his computer as a a guest on that Zoom link.
No,
And
just open Zoom here and I'll record it through this.
because I need to take my computer too.
Open it on hers.
What's that?
Open Zoom on hers.
That's I think what you're gonna do. Yeah.
Yeah.
All right. We'll make that happen.
So let me make sure I understand. Number 11 is this room?
Number 11 is virtual reality situation awareness, exact.
And
then number 12?
Number 12 has to go? Okay.
Yes, and then number 14.
And 13, no.
13, no, they just passed. That's
That was hell smoke?
hell, smoke, hell, yeah.
Okay. Okay. All right.
All right.
So, give me that.
Please.
I'm also recording here, backup, right?
Thank you.
Excellent.
Thank you very much, guys. I'm looking forward to have those, yeah. Whenever you're ready, guys.
Wait, I need to plug in so I don't run out.
Yes, so welcome to our presentation on VR first responder training. You kind of got the info before we stopped. But today we're going to be talking about various aspects of our project and the problem we were trying to address and how we went about that. We're also going to talk about the steps we took to reach our end goal and reflect upon what we did.
So about our project. We created a virtual reality UAV situational awareness scenario that's been integrated into Palladium Systems Fire Rescue. This tool will allow firefighters to be trained in a more realistic environment with the instructor able to give immediate feedback and evaluation. In addition, using virtual reality training methods, it drastically decreases the cost compared to real drones and increases the availability of training.
And we'll move on to the specifics of the problems we work to address. Drones are an excellent tool for surveying and have the potential to provide crucial information in emergency situations. However, the current training methods for new pilots can be costly and limited based on space available and the quality of the drone and parts you have access to.
Now, moving on to our potential solutions. Some of the ideas we thought about were an AI first-person view assistant that would support the user, the pilot, with modules that the drone would be using, or individual software that was meant for certification on drone situational awareness training. But what we came up with was we decided to work with Palladium Systems, who provided their wonderful code base, which we would integrate our drone with. So this would allow users to interact with drone and drone attachments to pilot drone in the virtual environment, and would capitalize on their ballistic fire simulation in VR to provide for a more ballistic training. The benefits included 24/7 training from anywhere in the world, with live feedback from the instructor to replicate events to improve experience, maintains realistic training mechanics that would carry over to the real world, and allows individuals to familiarize themselves with different drone attachments.
So next we have the project objectives and the methodologies we use to succeed in our project. So to start, in the fall semester, MECNI challenged us by creating functional requirements, which is essentially what turned into our desired objectives. So here you can see just a comprehensive list, but to summarize it, we wanted the instructor to be able to set the mission briefing, basically tell the user what's happening in the scenario. This would replicate a 911 call saying there's a fire on 2nd and Main Street. Other than this, we wanted the instructor to set a 3D environment, which we obtained. We also wanted the instructor to oversee the mission. Due to Play software, much of this was already integrated, so thank you, Fred. And also we wanted the user to see the mission details that the instructor had just set, control the drone going left, right, up, down, center. Along with that, we wanted to detect building information, such as saying, you're looking at a window made of this material, and we wanted the user to control the camera moving 360 degrees, as well as being able to switch from their view to the drone's view. And finally, we wanted them to know when the mission was complete. So the methodologies we used to achieve this, as many groups have said, we created a logical, physical, development, and process view. Each helped to guide us in our development. On top of that, we created a use case diagram showing how every interaction the user had a reaction and what would occur. We also created a work breakdown structure, which was a comprehensive list of everything we wanted to achieve. I believe we spent one late night going through it, saying how long each effort would take and what's this going to take and how much we're excited to do it. And then we also used the Agile methodology in the tools below. It says Trello, which we'll get to, but that's what we use for Agile to show what's in our current sprint, what we completed, and what we're going to do in our next sprint. And much of the testing that occurred, we would put into Play in system, make sure it compiled and performed as we expected. And the tools we used, of course, is Unity, GitLab to store the project, Visual Studio's code to edit the scripts associated in the Unity project, and Play in system software.
So going into our results and retrospective, so our completed objectives, going off of the list of desired objectives we had, we completed 7 out of the 9 objectives we set out to complete. With these 7 that we completed, and the instructor can now set a mission, and the user can now view that mission briefing and complete that mission with the functionalities we added, like drone escalation, de-escalation, steering, etc. And with that, we move on to our retrospective. So there were 3 main difficulties we encountered on this project. One of them was storage. As we kept working on the project and the software, we kept increasing the amount of storage, the amount of data it held, so we needed to have a bigger storage space. And unfortunately, GitLab and GitHub is very finicky with that, so we had to work around that. Of course, time was another big issue. We are college students, just like everyone else, so unfortunately we didn't have as much time as we would like to focus on this project because of other responsibilities and other classes. And the third was that we encountered a bit of a learning curve in the beginning because of how all 4 of us, or all 5 of us, have never really encountered industry code before. So a lot of the first few weeks of working on this project was actually all of us just meeting up together and looking at the code itself and deciphering what all of it does. But even through all those hurdles, our team had great collaboration, great communication, and it was honestly a pleasure to work with everyone. Unfortunately, with the setbacks we had, we weren't able to fulfill the 2 requirements, one of which was the building detection. Because of the way the scenes were configured, we weren't really able to implement building detection into the code. And because of the advanced input system, we didn't really have enough time to implement a switching from the first-person view to the first-person camera view.
Moving on to the conclusion. So when it comes down to the drone training, we were able to decrease the expenses and costs, visualize training, reduces risks of injuries. The instructor will be able to give live feedback to the students as they are progressing through the missions, and trainers are given the opportunity to test different virtual drone attachments. When it comes to the real-world impacts, we hope to improve response times for first responders, increase the mission success rate due to their better situational awareness, increase potential lives saved, and a faster and more efficient training for first responder drone pilots. When it goes to future work, we decided that we would like to integrate AI into our build to help the students with the modules, because it could be a daunting task to read out all the data that a dumb module might come back with, maybe gas metering or thermal imaging. We'd also like to implement map data API, say from like Google Earth on a live situation, and of course thermal imaging, which we have trouble integrating into this current build.
So next we would be doing a live demonstration, but due to technical issues, we're going to be playing a pre-recorded demo.
Okay, so here's just a video overviewing everything going on. This is the opening scene for Fire Science. Here you can see that there's a program selection, as well as module, scenario, time of day, construction, and experience, all allowing the user to customize how they interact with the software. So once it goes through, they are able to set Fire Science, which moves them into where we integrated the drone for the awareness, which is module 2 here. As you can see, as it goes farther down, it's going to show that you can add a drone to the scene, a microphone, a camera, and an iPad. Each has their own specific feature. The iPad is mainly used to show the mission briefing, and the other configurable items are for the user to use in the scenario. So in this moment, I'm loading into the game, and from there, I'm able to move around. Here is the mission scenario UI that we created. Highlighted on the right here, you see the items that they can include in the scene. Some instructors may not want everything accessible to the user or the student, so they can uncheck it and it will not be present. You can set the battery life so that the drone dies at a specific time or only at so much, because in the real world, we all know we don't charge everything 100% all the time. Then in mission briefing, you would be able to enter a scenario, like I had said, a location, or such as there's a fire at the University of New Haven. The user could take this information, know where to go, and kind of replicate what would happen in the real world. So next, for future work, we would like to progress and essentially make a database that would be used, establishing who the firefighter trainee is, where they are, what they're doing, and their experience level. This allows a relationship between the instructor and the student. And walking through all this, we're able to return back to the dashboard, submit this information to be used in the configurable scenario. Then once they spawn in, that's me standing there. So as I fly over to the drone, you see in the top right corner of the drone controller that the battery life is set to 50%, 55% as it was. And on this iPad, you see there is a fire at the University of New Haven. So from here, the user is able to walk over to the configurable items, pick up the remote, interact with everything you see. And from that, they can attach the camera onto the drone bottom, and then the live feed from that camera will be displayed on the remote control. So as you can see a little, the controller screen is moving, showing what the drone is seeing, and then we also allow that the user can pilot the drone in all directions. So that concludes our demonstration, and from from here. I believe we just have, sorry about that. We have our thank you page. Thank you for everyone who contributed in making this project a success. It was a lot of fun to work on. We all definitely learned a bunch and look forward to taking into our careers. And if there are any questions, please.
Are you using a handheld controller to interact with the drone when using the software?
Yes.
And is it similar to the controller that a firefighter would use to control it?
So we're using Oculus handhelds.
The Oculus,
And
okay.
when it comes down to it, it's similar in the way we handle it, not the controls themselves, like the controller itself.
Yeah, so I don't know how much experience you have with drone controllers, but
I have some.
so there's a joystick as there would be.
Yeah.
I believe the left one,
Left one's height. So the similarity between the VR controls and an actual drone remote are they're vaguely similar. The main similarity is the fact that you're using two joysticks, one for elevation and the other for left, right, forward, back. It really helps the pilots just get a feel for what that sort of movement feels like, because for a lot of people it's unnatural.
Yeah, it is. Yeah. Would it be an improvement to actually train on a real drone controller of the type that the employer would want to use? That I would think that would be important future work. It's very simple to have it communicate with your computers.
Yeah, ideally.
A simple like basic.
Yeah, ideally it would be the next step of having a separate drone controller. Sadly, hardware is a bit hard to do right now, but connecting the hardware to the, connecting the controller to the computer would add more additional difficulties, but it would be definitely something that would be worth doing.
Yeah, I mean, I agree that having two separate joysticks is a step in the right direction, but I think getting that touch right takes a lot of hours on the controls and would elevate the efficacy of your software to actually be training on the controller and having the reactions of the drone be as twitchy as we know a real drone control. Like, I'm very good at crashing. Okay? You know, driving things properly, not so much. Robots, drones, they don't let me drive. But, you know, because they are twitchy, there's a lot of learning involved. So I would think that that would be valuable. I think this is an incredibly important project and is going to help save lives of people.
thank you.
Yeah, great job. Great job. Yeah, I won't ask you how many hours it took you. But thank you again for bringing all of your enthusiasm and your creativity to the project. And I know it'll definitely have a positive impact. Firefighters all over the country will be seeing the fruits of your labors, and it'll keep them motivated to stay in and keep learning. So that's huge.
Yeah.
It's a pleasure.
Thank you very much.
Yeah, thank you.